Riley, Rye, feel better. Strings people, hopefully you watch this since you're gone at rehearsal. All right, so today we're dealing with the concept of proportionality, more with proportional relationships. So we see here the car paint company provides this graph for paying people. It's the manager pay. We can see from the title of the graph. We have money earned compared to hours worked. Almost always.
Excuse me, please. Can I have Greg Carpenter to the office, Graham?
Almost. He might not be here. And actually, I think he's in orchestra, so I don't know why they keep calling him. Almost always, when you have an XY graph and you have time involved, time is going to be your X variable. Shahib, you might as well just use the handheld. The black pencil sharpener kind of stinks. There's a handheld one right there. Almost always time is your X variable because your X variable is your independent variable. Your Y, the money earned, depends on the hours worked. You can't just all of a sudden earn a bunch of money. You would have to work to earn it, at least when you're an adult in the real world. Jackson?
We were just working on this in science class.
Yeah? You guys were starting to talk about slope though too, right?
Yeah.
So this is exactly right on with that. That's why Mr. Kabila and I were talking. We're like, oh, our stuff's going to be related. Good. Like we tried to get it to line up. I just couldn't get here fast enough. I wish I would have gotten here before he got you guys there because I think this will make more sense once we talk about it. But you know, if it helps your understanding, then good.
That was a really confusing word.
Yeah. So, but sometimes that's on purpose. Like it's supposed to be confusing at first. So, if we wanted to talk about a unit rate here, our unit rate is always the Y over the X. So it's going to be the money over the hours. And if it's a unit rate, it'd be the dollars per hour, per 1 hour. So based on this graph, how many dollars are being made each hour? Jackson?
$10 an hour.
$10, right? Because if I go to 1 hour, I have the point 10-1. And that is way off orient. Okay. If I go to 5 hours, I have the point 5 and 50. If I go to 8 hours, I have the point 8 and 80. Any of those, if I took my Y divided by my X, I'd get $10 per hour. That tells me that then my equation becomes Y, the pay you receive, will be $10 times the amount of hours worked.
You know you can orient.
I know, but I've done it twice already, and it still isn't working. There's like a glitch in my board.
Oh.
Yeah. So, I got it. I know. This is not my first rodeo with a smartboard. Fourth, really. All right, so our key concept here deals with if you have bricks. When I did landscaping, we would have to, and we had one of those cool wheels that would measure for us, and we'd go and we'd figure out, okay, we're going to build a wall here. We're going to measure the distance of the wall, and then they choose what kind of brick they want to use, and based off that, we know how many bricks we need to buy based off total length of the bricks, and then how many rows they want, or how many stacks. So we see one brick here measures 20 centimeters. What if we then got a second brick? How long would it measure when I add on the second brick? 40. What about the third brick?
60.
What about the fourth?
80.
What about the fifth?
100.
So then when I look at that ratio, so fill in your table, 3, 4, 5. I'm actually going to start using red then. So then we have 60, 80, 100. And same thing we did yesterday, looking for a constant of proportionality, but you didn't realize that's what we were doing. We were just setting up the ratios. We set up those ratios again and simplify, and the value that they get is my constant of proportionality. So since it would be 20 compared to 1 or 20 over 1, we really just say it's 20. So the constant of proportionality is 20, and that means that I can write an equation to say that Y, the total length, will just be 20 times the number of bricks. Now that would be way too easy. In the real world, it doesn't work that nice. The bricks are like 11 1/4 inch long or 8.5 inches. Like, it's annoying numbers. So I would always complain, why aren't these made differently? And that goes to aesthetics and the golden ratio, and it goes kind of further down the path of mathematics.
What's the golden ratio mean?
It's the relationship between length and width that is most visually appealing.
Isn't that feet?
Huh?
Isn't that feet?
Phi, P-H-I,
Yeah.
Greek letter phi, yes. This
My dad has it.
or this if you do capital, but yeah. What do you thought? So mathematicians a lot of times use Greek symbols to represent things. So that is like a Greek phi, and we use it to represent. I'm pretty sure we use it to represent the golden ratio. I'm not 100% certain, but considering you said that so fast, I'd probably go with you. So we're gonna weigh books, and I might as well let this video play because you guys might like it. So we've got our little detective dude, right? And he has really large pockets. So he's got 3 books in his pocket and says, you know what? They all weigh the same thing. Let's say they're all the History Alive books. They've got covers on them, so they look different colors. Drops them on the scale, gets a weight. His pockets are ginormous. Pulls out 3 more books. Drops them on the scale, gets a weight. Pulls out even 3 more books. Drops them on the scale, gets the weight. If you know that all of these books are identical, could we figure out the weight per book?
Yes. As long as they're
How?
identical.
Really?
Dividing the weight by how many books there are.
Yeah, if we want the weight per book, think about what I'm asking. Weight per book is just weight divided by books. So my total weight here is 15.75. My total number of books here is 9. And the really important part is that we know the books all have identical weight. That's why I said they're all the History Alive books. They all weigh the same thing. Same number of pages, same hardback cover. 15.75 divided by 9 then comes out to be, Nate?
1.75.
1.75 pounds, which we abbreviate LBS. How do I use that to then find the weight of 11 books? Okay.
Multiply 1.75 times 11.
Yeah, so we can say our total weight will be 1.75 times the number of books, which here is 11. We can multiply by 10 and then do 1 more added on to it.
18.25.
Okay, 18.25.
Wait, yeah. That was like.
You got to carry. Yeah, don't forget that.
I said that.
Yeah, Nate's doing it all on his paper. So small mistakes happen when you do it all on your paper. And that would still be pounds. LBS. Was it in this class that we talked about why I use the cursive L?
No.
It doesn't look like a 1. So when you're using L in mathematics, I encourage you to use cursive L because it doesn't look like a 1. Even capital L is not that great because we start to use the angle symbol, which looks a lot like a capital L. So I encourage you use the cursive L. And you're like, cursive, why? So try this. You're working at Foot Locker. Be a good place to work. Might smell a little funky. You're stacking boxes in the window. You assume all the boxes are the exact same. You're making some kind of Christmas display or something. I mean, you're going to start to see like ridiculous displays around the mall. What is our constant of proportionality? And you should be able to figure this out without a calculator. And then if your total stack, you're told, has to be 12 boxes high, I want to know, how tall will that be? And can you reach the top?
Can I reach, like, if you're tall?
Actually, better question. I'll tell you, you can't reach the top. What size of ladder would you need to reach the top? I'm going to take that problem a little bit farther.
Wait. I got it.
So the
Wait, is this
constant
right?
of proportionality is going to be the height per box. Well, first off, what's your constant of proportionality? How do you figure that?
You do 45 divided by how many boxes there are.
But how many boxes there are tall?
Oh.
These boxes over here don't matter because those don't change the height. Careful, Lily just sacrificed herself and pointed out the error that people like to make. This stack of boxes is all we care about. These other boxes out here, they don't matter. They don't change the height. We're looking only at height. So when you're looking for your constant of proportionality and you're looking for your height per box, your number of boxes should only be that stack that you see. Keep working. I want to know how tall of a ladder you would need.
How do you like?
Well, you know your height, right?
No. Oh
You
yeah.
should know approximately what your height is.
About 5'8". 5'2". So do you just say the difference?
I will tell you, 5 feet, 5 times 12 is 60 inches. So if you're slightly under 5 feet, you're slightly under 60 inches. If you're over 5 feet, you're over 60 inches by that much. So if you're 5'5", you're 65 inches. So Lily, did you save yourself? Did you find your new CP?
I think I did.
So what? Hey, what math did you do?
I did. Oh wait. No, I don't think I did it right. But I did 45 divided by 5.
Yeah, that's right. 45 divided by 5. Your CP here is 9 inches per box. So every box is 9 inches tall. Those are kind of tall shoe boxes.
Yeah.
And then the height of 12 boxes. Shahid, what did you do to find the height of 12 boxes?
I did 9 times 12.
Yeah. So your height is 9 times the number of boxes. So it's 9 times 12, which ends up being 108 inches. Guys, I can't even reach that.
It's 9 feet tall.
So 9 times 12, there's 12 inches in a foot. Jackson realized, wait, that's just like doing 12 inches times 9 boxes. So really this is 9 feet. So I would probably only need like a step ladder, like a 2-foot or a 3-foot small ladder. Yeah, Ella might need like a real ladder, like a 6-foot one or something.
I might get 89.
And if you want to be safe, you shouldn't ever be reaching off the ladder. So all of us should probably use a real ladder. So that's one of those situations where if your manager asked you to do that, you could say, look, I can't. I did the math. I can't reach that. But the one advantage is, like, I'm a little over 6 feet tall. Your arms are normally half the length that your body is tall. So like my arm span is about 3 feet, so I'd be close. Like I could almost get to 9 feet tall. Because when you like try it sometime, when you stand and you know like ceilings are 8 feet or 9 feet, your arms should be about half as long as you are tall.
What about those guys in like the NBA who have their arms like down to their feet?
You're 6
Well,
feet.
they're really tall.
You're like 6
right?
feet.
Or you're talking about like apes, arms down to their feet.
Basketball.
All right,
Basketball players are
try this.
chimpanzees.
You're planning for Phoenix Fair.
I'm sorry for the interruption. Could I please have Ethan Bartram to the office? Ethan?
Yeah, they called for Grant again. I was just gonna like see if I had his cell phone number. He took summer school with me, is why I probably do. Which isn't really an option for you guys this year. That's a weird sort of is it or is it not. So you're playing at Phoenix Fair. You are partnered up.
Could I also have Hayden Garrett, please? Hayden Garrett.
You're partnered up, and both of you have a recipe for cookies. You think, well, we can both use each of our own recipes. We can just combine them together. But then your mom's like, wait a minute. I know about cooking, especially baking. And you might want to make sure your recipes are the same. So, figure out here how can you determine if these recipes are the same. How can we determine if these recipes are the same? I can't hear you when you're mumbling.
He likes to
show how it can be the same thing you just
Yeah, show the math of how you got there. Really, since our lesson's all about constant of proportionality, you know that's going to come into play. I love seeing that some of you are really good at putting your name on your notes because about daily I find notes that are lost with no owner. What's up? You're not getting very far with
donate to help us feed these
So we
papers.
don't have to
So lost.
Easy thing to
These
do is
rusty papers.
bigger number divided by your smaller number.
No,
Don't
for
let them go to waste.
the paper orphanage.
12. So how many cookies does that really make? 36. So you could say cookies per cup of flour. And here you have 60 cookies from 3 cups. So again, you could say cookies per cup of flour. When you're asked for the constant of proportionality, it doesn't tell you what order. So it's almost always easier to take your bigger number divided by your smaller number, just how division works out nicely. So our CP here, we can choose to make it cookies per cup of flour.
Can I do this problem? I think I know.
Nate, walk me through it.
So first, since it has like it's 3 dozen cookies and then 60 cookies, you have to convert the 3 dozen.
Yeah, what
which
does
is
dozen mean?
12.
Dozen's 12.
It's in a group of 12.
So 3 times 12, we really have
36.
36 cookies. So to set up that constant of proportionality, we know 36 cookies,
For every 2.
yeah, can be made with 2 cups.
And then for 3 cups of flour.
Well, hold on, what's that simplify to?
Oh, 1.
36 divided by
Yeah.
2? 36
No,
divided by
18.
18. So that tells me we can get 18 cookies for each cup of flour that we use. Then for situation B, let's jump to somebody new. Ashton, yeah, you are here. People left, so I don't know who's here today. How do you find the CP for situation B or recipe B?
That'd be 60 cookies for over 3 cups.
Dude, use the handheld one. It's right below your hand, green and white. That's a pencil sharpener. Just use that one. It works better. 60 divided by 3. Sorry, Ashton. That gives me
20.
20 cookies per cup. Are these recipes the same?
No.
No. Now, wait a minute. What if I said they are the same? Your easy answer here is no. But if I told you they are the same, what could have happened to make these recipes seem different?
Oh, they left the dozen unchanged.
No.
Okay.
What is not fixed in this situation? When you think about cookies, how your mom makes your cookies compared to your grandma, compared to your sister,
How big they are.
how big they are. Maybe recipe A makes bigger cookies than recipe B. They could be the same, like they could both be chocolate chip cookies made with the same ratio of ingredients, but number of cookies is determined by the size that you make them. My mom would always give me a hard time because when I would help her make cookies, I would like dollop out the batter and like I'd have a lot like on the, and my cookies would end up huge. And she was like, "That's not like that's not good."
We
Like the
flatten
outer
it out on like a
and make
sheet,
just a sheet
and
of
then
cookies.
use a cup. And
Yeah. So
So they're
that makes
all-
a very standard size of cookies. But that's like ours, we just scrape it off the spoon. So that might be different sized cookies. But either way, no, they're not the same. Because their constant of proportionalities are not the same, there's something different. Even if it's just size of cookies, something is different. Lily?
Me and my friend Chloe were making
Howard?
cookies. Chloe.
Is it Chloe Howard?
No.
Oh, sorry. She was one of my students.
And we had enough batter left, so we put a huge cookie pie.
Oh
on the
gosh,
pan,
yeah.
And we cooked it for the same time that the other cookies were.
And it was
cooked
still
for.
like all gooey.
Yeah. So, but it was really good after we cooked it right.
Yeah, right, because you don't want to eat raw eggs.
Yeah.
They probably won't hurt you, but you don't want to chance that.
I eat raw cookie dough all the time.
Well, cookie dough that you buy in the grocery store is not the same as cookie dough that like you make at your house.
The stuff I make.
Yeah.
Making cookies, I always eat it.
All right, try this on your own. I want to know which day you ran faster.
I don't run fast.
I will go ahead and tell you, you did not run the same speed both days. My joke is I run when I'm chased, but actually I am running a 5K on Thanksgiving morning. So I can go eat a bunch of food then.
go to Mr. Hudson's.
After
All right,
we go
try
out,
it out.
like,
So
McDonald's.
you can
That's what
either
you
do
after baseball.
miles per minute or minutes per mile. It's up to you what way you do the division, but that will change how you have to look at which one is faster. So either you have to choose, are you doing miles per minute or minutes per mile? Yes, always. Well, in this chapter, always, because our numbers don't work well a lot of the time.
Yes, I know.
Wait, I was tougher. She's doing it for her.
Like, no, it's good. Okay. Over it.
We have to do is multiply by
I know.
Jackson. Giving everyone the answer.
Jeez, Jax.
Gosh,
look at
Whoa.
Gosh.
Now you took it too far.
that was from a point.
I know.
What is this? N R 0?
Oh, remainder 0. That calculator must be set up to give you the remainder. So instead of being in like scientific form where it'll give you the decimal value.
That's stupid.
So most of us have figured out that on Monday, when I do the constant of proportionality, if I do 22.5 minutes over 2.25 miles, that just gives me 10. But my label, very important, is minutes per mile. Tuesday, I have to set it up the same way we did on Monday. 25, because minutes has to be on top, miles has to be in the denominator.
Oh my, that's big.
Did you get it?
I got like.
Yeah, we can
Got it.
simplify
It was
it. You can
it's 10.6.
You can just simplify it because it's higher.
So
simplify it
10.6,
because it's
can I just round it
Yeah.
there? But again, that is minutes per mile. Which day was faster?
Monday. Tuesday. Monday.
What's your justification, Peyton?
Faster.
Yeah.
Because you want your minutes to be lower to make
Yeah.
It's just
It's less minutes.
Like in golf.
transfer.
If you're talking speed, you want to be faster. You want to take less time to do the same thing. Both of those constant and proportionalities are for 1 mile. And it would make sense that Tuesday would be slightly slower because you're probably tired from Monday. Shahid?
Oh, at first I thought it was a mile per minute.
That's why you have to have the labels. You gotta include that label so you can compare them and know what you're talking about. Figure out, and I bet you only need probably not even 30 seconds, figure out my pump rate of gallons per second. Or seconds per gallon, depending on how you want to do it.
The answer's right on it.
Carrie, when I do seconds per, well, which one, did you do seconds per gallon or gallons per second? So what's the division that you're setting up? Yeah, because if it's seconds per gallon, seconds has to be your numerator, gallons has to be your denominator, and we get 8. So that tells me it takes 8 seconds to pump out 1 gallon.
Is that a long time?
It depends on what you're trying to empty. If you're trying to empty a water tower, yeah. If you're trying to empty your pool, it'll probably take like a couple hours. Then, gallons per second would flip my division over, and we get, Olivia?
125,000 per gallons per second.
It makes sense that it's 1/8, because it's just the reciprocal. If we had 8 over 1 here, this is just 1/8. So now either of those is your constant of proportionality. Depends on what you're trying to solve for which you would choose. Does that make sense?
Yep.
Now if you're given an x and a y, my constant of proportionality is always the y divided by the x. Alright, we're going to skip the last one there because I believe that we could solve that pretty easily. Anybody who want to pass these out?
Oh no, another one.
We're going to run through this quickly.
Oh, yes. We're gonna have a work day soon though.
Yeah, probably Thursday or Friday. I'm just going to give you guys the day to work.
Don't make it be tomorrow.
Oh, I didn't say tomorrow as an option. So, all right. We barely move forward in this lesson. That's why I'm combining multiple lessons into the same day.
Yay!
So this lesson, all we care about is now we're dealing with equations that are going to be y equals your constant of proportionality times x. Because we said to have a proportional relationship, we have to have a constant of proportionality. There has to be a multiplier on our x. So in your notes, you'll see you have this right here. I would highlight, circle, star, do something to notate that y divided by x is your m value. M stands for our constant of proportionality.
I get it. Why don't we just do CP?
Because we don't like using multiple letters as variables because it looks like it's 2 different variables. And m also represents the word multiple. Y is a multiple of x.
Gotcha.
M is a multiplier. It makes sense to use M. M, for you guys talking about that science worksheet being hard, is also the slope. So your constant of proportionality is the slope of the graph.
Whoa.
And the slope can be represented by the change in y over the change in x. The triangle is the Greek symbol delta, which we use for change in.
Yeah, he told us about that.
Other questions, comments, concerns?
Nope.
I like that sigh of oh, that makes sense. What? So, your friend uses the equation y, the total cost, equals 8.5 times x. X is the number of movie tickets. What is our constant of proportionality in this situation? Not the whole class. Seth.
I'm so confused because I wasn't here yesterday.
Grace?
8.5.
Your constant of proportionality is just whatever multiplies by x. So it is just 8.5. But since it's money, I'd prefer that you put 8.50 because it really represents, well, B asks you, well, what does that represent? If this is telling you the total cost will be 8.5 times the number of tickets, that barely looks like a decimal.
That means
Peyton?
that it's $8.50 per ticket.
Yeah, it's $8.50 per ticket. which is relatively standard for around Columbus.
That's expensive.
Then to calculate, now show your work here.
Oh.
To calculate 13 movie tickets, we're wondering what is the total cost. 8.5, or we can put 8.50 times 13 tickets. Let's say your parents say that you can go to the movies and take 10 friends. So it's you, your mom, your dad, and your 10 friends, 13 people. We want to talk about how expensive some of these things you guys want are.
Oh my gosh, that's a lot of money.
I know.
Cheap?
I quick comment.
Okay, real fast.
A while ago, my dad told me, because I think that I constantly always wanted to go to the movies, and one day he told me that sometimes the tickets cost way too much, and it's like, I was like, how, Dad? Could it be? I thought it was
Yeah.
$1 or something. I was little. Then he pulled it up online.
Yeah.
It was like $20-something.
To take 3 people to the movies is normally as expensive as to just buy the movie once it comes out. And actually, if you go and you buy food and stuff, really it's only 2 people. That's why I normally Redbox, or if I go to the theater, I go to like the quote-unquote dollar theater down at Carriage Place.
Yeah.
It's like $2 or something.
We
But
buy it on like our PlayStation.
yeah, like rent it or
Because it's-
whatever.
No, we actually
Oh,
like
yeah.
buy it. It's cheaper than.
What's our total cost here, Ella?
$110.
And 50 cents.
Wow. That's right. Yeah.
Wait.
13 people.
So guys, that would be over $100 to go to the movies. Or, this is when you think about like planning things. What if you took that $100 and just bought things to have a party?
That would be right.
And then you could buy like chips and soda and then rent a movie for $1.
I would buy a karaoke.
Okay, it's like $1.20 set. Like Redbox added some.
Netflix.
Yeah, or Netflix.
Netflix
watch
and everything on it.
I guess.
So Noah's
Netflix
gone
and
too.
chicken.
Zach is gone too.
Yeah, he's
I'm here.
Leah, in the equation P equals 4S, what is our constant of proportionality? This is in the form of y equals mx, but instead of y they used P for perimeter. Instead of x they used S for side length. Do you know what our constant of proportionality is? You can always pass it. 4. It's whatever is multiplied by your variable. So really you're looking at what variable's alone. Whatever variable's not alone, it's going to have a multiplier. That's your CP. So my constant of proportionality here is 4. And then if we had a side length of 1.6, we could just plug that in. We can say the perimeter will be 4 times 1.6. You shouldn't need a calculator. We can distribute out this multiplication. 4 times 1 and then 4 times 6. Scoot your decimal point, add it in, and we get
6.4 meters.
making sense?
Yeah.
Does it make sense to you guys why we're running through 2 lessons
I'm
in one
making
day?
dollars.
Ah.
Get it? Right? Am I right, guys?
Air high five.
So now
Air high five.
one of the biggest parts of your homework. One of the biggest parts of your homework is going to be to read a verbal situation and choose an equation or write an equation that represents it. So a certain vegetable dip has 60 calories per serving. What equation would represent how many calories you eat Y after X servings of dip? I don't care about using these equations over here. I really don't care. We're going to write our own equations.
Is that the right
So
one?
Karen?
Y equals 60x.
Yeah, if it's 60 for every serving you eat, it's Y equals 60x. Because X is how many servings you have consumed. At a telethon, a volunteer can take 60 calls in 5 hours. What equation represents the number of calls Y a volunteer could take in X hours? There's some work to do.
Y equals 12x.
I keep wanting to R when I look at you.
R.
But yeah, we figure that out by taking calls, since calls is our y and x is our hours. Your CP is always y over x. So it's 60 over 5, we get 12. So that's how Olivia came up with y equals 12x. And likewise in the last one, James, I haven't talked to you yet. What's your constant of proportionality for that last situation?
Is it y equals 5x?
It is y equals 5x, because if you take your 60 divided by your 12, you'll get 5. So they can essentially make 5 keys per minute.
Wow.
It's a lot of keys. Jackson?
Okay, I feel so dumb for just now realizing this, but in all of those equations and in every equation like this, you can always tell what the constant proportionality is because it won't be a variable. Because variables can sometimes change. So if it's always staying the same, then it's a constant. And I'm like,
I brought that up, I think yesterday. Probably because it was Monday. But the fact that a constant of proportionality has to be a number because it's constant. But it's the constant of proportionality because it multiplies by something. As opposed to, because don't get confused, you are going to end up using equations in the y equals mx plus b form. And this is also going to be a number, and it is just your constant. Not of proportionality, but it's a constant because it's a number that's added or subtracted on. It just stays the same. So we have a constant and a constant of proportionality. That's why we just introduce it right now with the y equals mx form. No plus b to worry about. Try this. Write an equation, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. We want to buy apples for the whole class. So you then also want to answer, what will 16 apples cost? Write your equation and then solve for what will be the cost of 16 apples. Your face when you look at him. Please. You got like the puppy dog eyes. I know it, I really do. I worked hard. I got my work. I did it. What work did you do, Peyton?
Okay, so you have to do 250 on 2.50 divided by 5. Make your constant of proportionality 0.5.
50 because it's money. We want to use 2 decimal places.
And then you do y equals 0.50 x, which then you multiply 50 cents times 16.
And without a calculator, you should be able to figure out half of 16. So if you wanted to bring in apples for everyone, it'd probably cost $8. Now those are probably like good apples. Well, actually, that's not actually that much, man.
I mean, if you have if they're bad quality, then.
Well, yeah, but who's buying bad apples?
At lunch, our apples are really good at lunch, and they only cost 50 cents.
Yeah. See, there you go, 50 cent
We've got a
apples.
cheap apple.
Bad apple, that's a song.
A bottle of water in the cafeteria costs like $1.
Yeah.
Bad apple.
Beverages are always overpriced. So here is an example of the exchange rate. So this is just an intro, just giving it to you. If you know that you get 45 rupees for every dollar, then your constant of proportionality would be 45. It's going to be 45 rupees per dollar. So if we take that situation and look here, like in Spain, pay attention. The biggest mistake you're going to make on your homework is which variable goes with which label. Here, euros is my Y, X is my US dollars. So my constant of proportionality is going to be found by doing euros over dollars.
So euros divided by dollars.
Yes. Now one of these rows is much easier than the rest.
Oh, I know which one it is.
Nate?
The second one, 75 divided by, or over 100.
Because then we just get,
simplified to 3/4.
yeah, or 0.75. So we could say that our equation then is just y equals 0.75 times x, or the rupees that you'll get, sorry, not rupees now, euros, the euros that you get will be 0.75 or 3/4 times the US dollars. You can change your variables, but in standard form, how we normally work with it, we use y and x. That is all the time that we have for today. The rest of the lesson, we're okay without going over it. So please let me know if you have any issues. Where are you guys headed now? Oh, you're going to family room then. Somebody before lunch or at lunch should ask me if I posted the homework.
Okay.
Because I keep forgetting until we get to AO, and then I feel bad. So, yeah, because I can't do it right now because I've got Math 2 coming in.
I'll ask once I get to it.
What? Yeah, probably. I'll just go ahead and put them all up. Why?